Today kita akan do our class, but it is asynchronous, which is you need to learn on video that I share and also on the module that I share to you. And I just want to see whether this method is okay to you or not, as I do believe that all of you will having internet connection problem. You also have a problem with your data of your internet, sometimes maybe also about your time, because I don't know whether you are free at that class or not, although it's already occupied for my time, my class. But there is also a lot of students saying that they cannot attend, and then there is also a requirement from other students that they live outside from Malaysia, which is our time zone is different. Maybe up here in Malaysia it is 2 p.m, but over there it is already 2 a.m, who knows. So but that's happened to my other subject. I hope over here we will occupy any method and combine it all together. So I did this video as to share with you, so that you can use this video as your reference after this onward. And this is as our lecture for today. So high performance and parallel programming. Before we go deeper, our previous class we just do the introductions. I get to know all of you, you get to know about me. So now before we go further, I need to share with you about our course information. So this course of information, I already uploaded it in our e-learning. So please check your e-learning time to time. I do believe that all of you is third years and you're quite familiar with your e-learning. Okay, this is about our course information. So for this semester we have two sections, which is section 1 is me myself, Dr. Nurhaliza Binti Wahab, and section 2 is Dr. Ismail Fauzi. So for previously one section handled by Dr. Ismail, so he quite mastered in this subject. So if let's say you want to refer to him also, any question you are allowed to, but don't make him like you always refer book 24/7, which is he also have a lot of other subjects to handle. So on the synopsis, so you can also read through all of this, what we're going to look into our subject and etc. Over here there is information about us, our phone number, our email address, our office, and you can just come by or also contact us through our email and also our phone numbers. And about this course, this is 3 credits our subject, and there is overall 4 CLO to accomplish for this subject. For CLO you can read all together by yourself, but what is the most important about your course information, of course I do believe that you all had reading a form, but you need to see all of this because you need to know what is your objective for this subject. Like this one, your CLO, what is the objective of CLO1, what is the objective of CLO2, and etc., and where all this CLO will apply, so you know basically what you need to do and which one you need to aim. So this one is about hours, student learning time, SLT details. This part is the one that I want to share about the marking schemes for about marking scheme for our course, which is first one is quizzes. There is under PLO1, and then the percentage of our quizzes is 9. And there is also lab programming test, because mainly this project this subject is about programming. And about assignment, assignment is 10%, and then the lab programming 12. Test, there is also test, so you can see there is test 1 and test 2, I think. And after that, about the project report and also demo, the project report from your lab and the demo, and finally is on your final exam. You can see that the percentage of final exam is only 30%, so all the rest is on the assessment. So please make sure you can aim to get higher in your course assignment, which is quiz, lab, assignment, test, project, and also demo. So no need to worry on the final exam much, because you already occupied 70% only on your course assessment. Is it okay? So if let's say you forgot, you can always refer to your this course information in the e-learning. So what you're going to look into is on the module 1, introduction to high performance and parallel computing, and then there is a module 2, parallel computers and architectures, module 3, concept of process and thread, module 4, revisions of C or C++ programming in Linux terminal environments. We're going to use our Linux, and basically we can use Ubuntu, because I think Ubuntu is the friendly user for Linux base. And then module 5 is Machine Passing Interface Programming, MPI. This is the one that I already mentioned to you in our first class, that we're going to use MPI. And then the module 6 is under MPI communication, point-to-point communication, and another one lastly, not last, which is before your midterm SEM break, which is on your module 7, MPI communication under collective communication. So there is also assignment on that. You can see when is your quiz. Your quiz 1 is on introduction parallel computer. It will happen on suppose in week 2, but I can see that we're going to do it next week. So the quiz is basically all online in the e-learning itself. And then there is quiz 2, which is under process, concept, and etc. And then week 7 is for your group project assignment under your programming lab test 1. And then midterm semester test, quiz 3, everything was started here until your final week, which is revision weeks for your final exam. Before that, you have a group project presentation. So this is basically all about your course information. I hope that you can go through it, or this one is important, that, and you can just refer to it. So let's we take a look into our mainly, which is about our module 1 on high performance and parallel programming. So let's take a look on this. Okay, over here, what we're going to learn is what is basically high performance computing. So I don't know whether you wonder about it or not, or because you already third year student, you don't think that you are asking about subject you learn, because it's basically already assigned. Oh, I need to take this subject. So I think you need to find what is high performance computing. And over here, I already listed high performance computing or parallel computing nowadays is widely used, and the purpose is on execute complex system and also computing of complex problem. We can solve it using HPDP or high performance data processing in the minimal time. So this is the keywords that you need to know when we have the complex system and also complex problem on our system and computing. We want to, of course, to solve the error, to solve the problem, but in a minimal time. Let's take a look. There is a lot of keywords on and also, let's say you're a programmer. You can see that there is a short form or uh, short form for the programming, or also you can use the keyboard as a short form for you to type something. So it is all about engineering and programming. They let me say it as lazy to do something in a long word or in a long time. So why don't we can, if let's say we can use it and solve the problem in a minimal time, why don't we using it? So that is the purpose. We need to learn this so we can solve any problem with a short time. And then this course introduce us to architecture of parallel computing. So you're going to see what is parallel computing, what is the parallel algorithm. This both quite similar in word but different in meaning. And another one is parallel application. So all of these you will use the MPI open source and also OpenMP package, which is what our programming language is on C or C++. So this is about only introduction. Next is, this is what I want you to ask yourself. What is the use? What is the need for you to learn the high performance computing? So what is the use? It's to enable you to solve bigger problem faster, which is in a minimal time, and then you can get answer or you can solve the problem. This is the use basically in a short form of word. And then another one thing is about how you can solve the problem in a fast way. How high performance computing can help you to solve this problem, to fasten you to do any project in a minimal time. So it use, which is integrating many processors, memories, storage device to add as one full system. So everything you integrate it together and you will do on the setting and etc, and you become it as a powerful system, one powerful system. So what is the key? The key is it efficient, stable, integrating, which is like over here, and HPC or high performance computing networking under a software and expert. So this is just an overview of HPDP. So next, on outline of this module 1, which is very basic basically. First you're going to learn on the concept of parallelism, and then the parallelism is computer program, the opportunities, and lastly on the computing and distributed computing. So without waiting and delay, let's take a look the concept of parallelism. So there is three It's easy to remember because there is only three. First is parallel computing. So although the keyword parallel computing and parallel computer quite similar in words, but there is different in meaning. Another one is parallel programming. Of course, it's about programming, but under computer and computing, what is the difference is for parallel computer you have multiple programming, but it's one computer. There is no S over here, which is we talk about one computer or one devices, which is PC or your laptop. So you have a multiple processor inside one PC. So over here, your computer system, which is uh, having all these multiple processor that support parallel programming. So let's say the example is you have one PC, you open Windows, you open Words, you open PowerPoint, you open application WhatsApp, you open your chat operation application, you open your MPI, you open Linux in the same time. It means that you open many programs or application in one time by using a multiple processor. So this is parallel computing. This is only one computer. So this is the system. But on the parallel computing, another one is about parallel computing. So for parallel computing, you can see that you use parallel computer. So you use this and you apply it on the parallel computing just to reduce any problem which is related to single computing problem. So you apply the parallel computing inside parallel computer. Sorry, you apply parallel computer to be applied on the parallel computing. And lastly is on a parallel programming, you have the computer programming in a language that allow programmer to indicate how different portions of computing or computation might be executed concurrently by different processor. So you're going to have a different processor and how the programs inside your computer can indicate the portions of computing in one or in multiple different processor. So three concept only that you need to remember. So I think it's not very hard for you to remember of the concept of parallelism. So this is what is the example also include on the concept of parallelism, which is it is not a new thing. You basically have heard about this before, and people also always talk about it, and it is a familiar concept in human life. For the examples in juggling activity of person, in constructions of human or building, in manufacturing, and also in customer service, just as the examples is call center. So here I show you, let's say after this I will share you also another notes, which is there is examples on the call center, so that I will put it on the learning and concept of parallelism. So this one basically is quite similar, but on very detailed examples like parallel activities in construction, which is under house and building, is about wiring, plumbing, roofing and each, which is different the degree of parallelism and etc. And this one is activity in manufacturing, this one is activity in call center, and lastly example on juggling. So this is just example for the parallelism. So what is basically the example that you can understand? You can go through and read it, and I also will add another extra modules just to give you the overview and example basically on this concept of parallelism, so I will add on another notes. What is the opportunities and this parallelism, which is there is basically a 5 of this and more. So existence of multi-core computer, existing of supercomputers, a cluster, availability of services, good computing, and etc. So you can go through one by one. If I just reading the slide, it is not supposedly to be happen. And you need to know also what is the difference between these all, because after this video I will assign you to see on what is basically you understand on this video you learn. So you will be okay. After this you check your learning and you need to submit this by end of this class on 5 p.m. So parallelism computing, this is
which is parallel computing. This topic, or this way of computing, I should say, has been very, very popular in the past years, and there's a specific reason why, which I'm going to discuss in this video. But let's have a look at traditional computing, the type of computing which is not parallel. So we have the processor here, and the instructions come in, and the processor does the processing, and then you have the processed data here. As you can see, there's a queue of new instructions coming in, and the processor is doing its job, and then we get kind of processed data out of it. Now, there's a problem with this approach, especially in the past couple of years, and the problem is that we can only make this processor faster to a limit. There is a frequency limit, and the reason there are plenty of reasons actually, but one of the important ones is heat, because these processors are very, very kind of condensed. So the amount of heat generated by electrons moving through the processor is very, very high. And that's one of the reasons why we can't really increase the speed of processors, one single processor, because it will melt down. So because of this reason, we had to take a different approach. So if we want to increase the speed, but we can't really increase the speed in one single processor because of heat, then what can we do? So one thing we can do is to increase the number of processors. This way, we have two processors running simultaneously, and we divide the tasks between these two processors. This is called parallel computing. Two processors running at the same time, doing the calculations, and we divide the workload between these two processors. Of course, this introduces a new set of potential problems, and one of them is more bugs, because you should know when first which instructions you need to divide and what instructions need to be dedicated to each of these processors. Because let's say that you assign kind of a process to this processor here, and that task gets done fast, but this task is dependent on a process which is currently being run by the other process here. So you can have a kind of latencies, you can have a different kind of problems when it comes to writing programs for parallel systems. Of course, majority of computers, especially since past couple of years, all the computers are running on multi-core processors. So that's another thing. Each processor in the modern computing is called a core. So a quad core, a dual core, that's basically, that explains the number of processors running at the same time. So this is a very, very short video on what parallel computing is. We also have this.
Okay, that is the basically about video for parallel computing. The example I just want to share with you. This video is also available, so I think I put it on one of the YouTube channel, so you can also look into that after this. I don't want to touch basically on the Flynn taxonomy. I think this is just really basic what I shared in this video. That's why after this I will share also another video to you. What is the purpose of this video is just to check your understanding on, if let's say you are given the video on one topic, do you understand it basically or not, and this is the purpose. So after this I want you to draw a map on differentiation between parallel parallel computers, parallel computer and parallel computing. Another one is the parallel programming. So you need to draw the mind map of difference between these three. So I think only that. Thank you for your watching and having a good day. Bye.